Hi everyone, thank you for joining me. It's my talk, Beating the Pentester. So this is me, my name is Baukema, and I am a software developer with over a decade of software development experience in PHP. I am also a security consultant with close to a decade of experience with that. I currently work as a senior application security consultant with CA Technologies Veracode. That is the application security division of CA Technologies, and we offer both manual and automated static and dynamic analysis of source code or binaries for security inspection. So that's a really complicated way of saying you give us what you deploy and we'll find bugs in it, security bugs specifically. My work, however, starts after that. It starts when the flaws have been found and the report has been created and has been handed down to the developer to fix. Typically, a developer will have many questions about that report, and they'll pick up the phone and they'll call me. So I help developers fix, or what we call remediate, flaws in over 30 different programming languages, technologies, frameworks, and environments. So that's me. I help developers. I'm on your side. This is Adrian. Adrian is a pen tester. This is short for penetration tester, but everyone really just prefers pen tester. Typically, Adrian is called in at the end of a project. So the software's been built, it's ready for production, and of course, as developers, we'd like to do more, but we're reasonably sure that this is ready to go to production. Adrian is then tasked to prove the exact opposite by finding as many security bugs as he can, putting those in a report with scary titles like high vulnerability or medium vulnerability, and giving that to management or your customer that can't understand the technical bits but just see high vulnerability. Ooh, that's critical. We need to hand it off to the developer to fix as soon as possible. And of course, there's no time for it because someone just took a pen test and didn't think to actually take some time to fix the flaws. And Adrian's not helping. Adrian's off to his next project. Adrian is the enemy. Adrian finds flaws in your software. Adrian is proud of what he calls the breaker mentality. I say that, as the saying goes, an ounce of prevention is better than a pound of cure, and the best defense is a good offense. So with that in mind, let's take a look at beating the pen tester. So we'll start out with an introduction, then we'll go over to bare fists. Okay, so that's a joke, right? I know Adrian's a good guy. I don't really advocate violence against pen testers to solve that. Doesn't solve anything. Be sure no pen tester was harmed in the making of this presentation. I actually believe that the best way to defeat pen testers is to look inside their mind and see what they know. And what does a pen tester know? What does he think about? Well, he thinks about ways to attack your application. And where might he find those attacks? Well, helpfully, we'll be taking a look at some of the most dangerous ones today. And the penetration tester would rather be lazy than tired, of course, just like a developer. So the first place that a pen tester will try is to actually look for known vulnerabilities in your software. So where will we start? Well, helpfully, MITRE has a project called the Common Weakness Enumeration. This has a list of flaws typically found in software as it relates to PHP in this instance. However, these are weaknesses, and that still requires work on Adrian's part. You can think of the weakness as a sort of the class of the vulnerability. It is the underlying principle that a vulnerability can be found from. A vulnerability is something that's actually exploitable, and that's what Adrian hopes to find. Fortunately, he can find that online too. So if you're building a software project, then you likely are hosting a lot of software that wasn't made by you, that was made by a third party. And that third party may have had vulnerabilities found already in its software. So this is the website cvedetails.com, which helpfully lets you search for and sort common vulnerability enumeration data. In this case for PHP with anything that has a score of 7 or higher. And if not in the software that you're using, then maybe in the packages that you're relying on. So unfortunately it falls a bit off the screen there, but this is a screenshot of the Senzio vulnerability database, which lists vulnerabilities in packages that you can install with Composer from packagists. Or why work even that hard? What's even better than a vulnerability is an exploit. So ADM will typically also look on a site like exploitdb.com, which is the GitHub of exploit code, or he might take out his copy of Metasploit, which is a framework specifically for attacking known vulnerabilities, and download one of the modules for Metasploit to attack your application, attack your server, and install something like a Bitcoin miner on it, just for fun. So that will typically be the pen tester's first method of attack. He'll look at what you're running, and he'll look at it not only at your application, he'll look at the frameworks that you're using, the libraries that you're using, the PHP interpreter, he'll look at the web server, he'll look at other services that you're running like Memcache, like a Redis, and he'll look at the operating system. And depending on the scope of the pen test, he may even look at other applications installed on that same server. Now, that's one big difference between a pen tester and a actual attacker. You can tell a pen tester, just look at this application, don't examine the other ones. And actually, an actual attacker, you can try that as well, but that'll just make him more interested. And this is a valid threat to look for, because this is A9, the OWASP top 10 known vulnerabilities, and it's actually the one most associated with actual data breaches in the wild. Because as we speak, bots are out there crawling the web, looking for known vulnerabilities, and they don't specifically care about your application or your server. They just want to compromise a application or a server, and yours will do just as well as any other. So what's our defense against this? Well, monitoring and patching. You should regularly check for new patched versions of the third-party software that you're using. And you should be able to update that as soon as possible. It does you no good if you can find a patch for a security version, but it takes you 3 months to deploy. So something like DevOps, that's not only helpful for application development, that's also helpful for security. And actually, DevOps does compound this problem a little bit, because in the past, where you would deliver a tarball with your software to your operations guy that has only your framework and your libraries in it, with something like Docker, what you may be delivering is actually a PHP interpreter and a web server and lots of other services that all need to be checked for vulnerabilities, for known vulnerabilities. But who is going to do that? If you're delivering that Docker image, then that should be you. Oh, and by the way, did you know that the Docker Hub, also 40% of the images found on there have known high vulnerabilities? That's not 4%, that's 40%. So be aware when you're using something like Docker. I once knew a guy that submitted a package to something like Red Hat, to Red Hat in fact, and his biggest remark on the process was exactly how determined these package maintainers are at extracting every little bit of third-party software from your code. Even something as simple as jQuery plugins. Why? Because if a vulnerability is found, these maintainers don't want to update 50 different applications. They want to update one library. So my message here is, with this great power that Docker gives you comes great responsibility. Now let's look at the second most common attack, or rather it's an attack class. It's injection. And for this, actually, I personally blame one person. I blame Doug. So in 1958, Malcolm Douglas McIlroy joined Bell Labs. And from 1965 to 86, he was head of its computing research department. Now, if that rings a bell, pun intended, then that's because many great things were invented there, including C, C++, and Unix. And in 1978, he published in the Bell Systems Technical Journal what would later be called the Unix philosophy, and that consisted of 3 points. Number 1, write programs that do one thing and do it well. Number 2, write programs that work well together. And number 3, write programs that handle text streams, because that is a universal interface. And almost 4 decades later, we are drowning in text interfaces. Just about everything that goes into our application, everything that goes out of our application, and even some things inside our own application are being passed to some or other interpreter. Note that these are all injectable contexts, by the way. So even something as simple as CSV, the common separated values format, can be injected with a simple comma, changing the meaning of whatever column is used. Or an attacker may choose to start his input with an equal sign, which when opened in a program like Excel may mean that it'll trigger the execution of a macro, which is actual runnable code on your victim's machine. And some interpreters have helpful features, like the XML parser, which has a feature that lets you define your own entities. And oh yeah, fetch the definition of this from the URL, from a URL somewhere, or from the file system, which ends up with the attack XXE, or XML injection, where you can include a file from the file system and embed it in that XML. Now, all these text interfaces, they end up with, sometimes we end up with some really complex scenarios. So let's take a look at one of those and see how we can deconstruct it and make it safe. So you might imagine this to be a little subtemplate of a subtemplate of a subtemplate hidden away somewhere that provides the ability for one user to message another user. And this little subtemplate, oh so small, this actually instructs 4 different interpreters what to do. First, there's our PHP code. PHP will parse the template and will replace the variable by the actual contents. Fortunately, there was no eval being used or variables, so there's no dynamic stuff going on there. There's nothing that can be injected against. Then, once it's parsed, it'll be sent to the browser, and the browser will then parse that document, that HTML document, and once it reaches the script tag, it'll stop. And it will say, well, this is JavaScript. So I need to start up a JavaScript interpreter, and then everything I fetch will be passed to the JavaScript interpreter, unless it is a closing script tag. That will be important later on. So then the JavaScript interpreter, that interprets an object, and that object then has a URL. And that URL, let's try and see if we can attack that. So how we can attack that is pretty simple. We inject control characters that have special meaning in the underlying protocol, which is the definition of injection. In this case, we inject the redir argument, and this may cause a user, if he needs to message another user but first needs to log in, that may cause him to go to Adrian's evil website instead of to your own website, if that website has or if your application has an open redirect vulnerability in it. However, this still requires an open redirect vulnerability. So let's see if we can do better. Let's see if we can break out into JavaScript. So The way to break out of JavaScript in this case is to close the string context, close the object context, close the statement context, and then basically inject your own JavaScript. Finally, in order to make sure that you're not actually causing JavaScript errors, we open up another object context and we just ignore the string context by ending it with 2 slashes, meaning a comment for the rest of the line. What results is what is below. So the ability to inject your own JavaScript. And with that, if your cookies have not been protected by something like HTTP only, then an attacker may use that to steal session cookies and send them to his own evil website. Or he may just simply rewrite the page and show a login box that will, and your user will then log in, and the attacker may log those credentials to his own website before logging the user in, thereby stealing the credentials without the user being any the wiser. So that was already pretty powerful, but still we can go one level higher. We can break out into the actual HTML. So remember when I said that what happens when the browser sees a script tag is it stops, but it will still read everything because it has to look for that closing script tag. Now, we can simply inject a closing script tag in that JavaScript string, and the browser will see the closing, the HTML parser will see the closing script tag and just immediately stop the execution of the JavaScript engine, which will give an error for the JavaScript engine, but that's okay for the attacker. In this case, we can then include a link, or basically anything we want, another script block if we wanted to. So as it turns out, one important defense against these types of attacks is actually a software design best practice: separation of concerns. We are doing way too much in this one template. We are building a URL, we are encoding it to JSON, oh yeah, and we're also making sure that it's safe for an HTML script block. So let's separate out those three, and let's first build the URL properly encoded with the URL content or URL encode. Then build the JSON, properly encode it with JSON encode, and finally make sure that it's safe for an HTML script block. Now this also implements the security principle contextually encode as late as possible. This is a toy example, of course, but in a real system, make sure that you're not encoding as soon as possible, or you're not encoding too early, because you might end up encoding for the wrong thing. Encoding something for HTML that's supposed to go in JavaScript or JSON, that might give you, that might still open you up for attack. So if you've been programming for a while in PHP, you might not actually know that HTML script content function. And you'd be correct, because I wrote it. There is no such thing in PHP. Also, you'll note that it doesn't end in encode. And this is another common scenario, because the HTML interpreter in the browser, that doesn't have any encoding for /script. It's simply not there. It's not valid in the script content. So we need to guard against that. We need to look at the other side of the coin. And that is validation. So my first question when it comes to validation is always, does your data have a data type? Note that in PHP, data that's coming from the request can be either a string or an array. And treating one as the other may have some dangerous consequences. Secondly, I always ask the question, can it be of infinite length? So we have a static engine which parses through source code, and for some languages we detect whether or not validation has been added. So when development teams come to me for consultation, one of the typical things they say is, well, this is coming from a WYSIWYG, so this could be anything. We don't really need to implement some validation on here. And my favorite reply is always, okay, so can that be 1 terabyte of data? If so, I'll happily cancel my Google Drive subscription. host my data on your servers. Your data is always constrained, at the very least, by size. And especially if you're using a storage system, something ancient like MySQL, which may silently truncate the data that you're sending it, then it's very important for you to validate that indeed you are using the correct size and that you're not allowing unbounded input in there. But also, nearly always your data should conform to some pattern or other. So if you're using a URL that has a known structure, a phone number, unless it's a commercial, you wouldn't expect alphabetical characters in there. If it's something that's coming from a checkbox or a dropdown, then that's certainly something that you can validate. And at the very least, you probably don't want to be allowing binary data in the vast majority of your fields. So checking whether it's UTF-8 and has printable characters in it, that might be something that's worthwhile. So if you're looking for more information on this, the phpsecurity.readthedocs.io has a lot more information. So let's look at that HTML script content block. So what we're doing here is applying the concept of defense in depth, actually, because if you're familiar with JSON encode, then you'll note that JSON encode already automatically escapes all forward slashes with a backslash. So if all you're using is JSON encode, then you're already safe. But what then happens when a junior developer introduces an echo or doesn't use something like JSON encode? Well, that opens you up to attack again. So the best way to ensure that you're not having this injection is to validate that indeed you're not having this injection. And that's all well and good, these validation, but what if there was some way to combine both the data and the validation that was done on it? So fortunately we have objects, so something like an immutable value object is an invaluable tool for that. Again, we see that best security principles heavily overlap with best engineering principles. If you're injecting your value in the constructor and using something like an assertion library to give you some nice little syntax helpers, that can just make that validation effortless and ensure that you're using that validation throughout your program. So these are just the two most dangerous ones, and this is just the tip of the iceberg. I would encourage all of you to take the red pill and learn more about application security. The OWASP Top 10 is frequently referenced. It's a good starting point. My favorite project is the OWASP Application Security Verification Standard, which is a way for you to check the security, just a basic checklist of how you can check your own security of your application. If you want to learn more about pen testing, then you can go to the testing guide. We already talked about the common weakness enumeration. PaulSec has some awesome security talks, hours and hours, hundreds of hours of security talks. And I would definitely recommend looking into the HackerOne public disclosures, because that shows you that even the big names fail sometime. Another way to speed up this process is training. I'd recommend the Zen certification, not because of the Zen certification, but if you're getting started out, that has a good basis level of security content. If you have any questions after that, then I definitely recommend going to OWASP or a security vendor, and they can help you further with additional security content. So make sure that you're, when you're going out there, you'll run into lots of deprecated attacks. So you're running into, for instance, the null byte attack, which have long since been solved in PHP. You'll run into the script injection, which if you're using JSON encode, might not be so prevalent as you might think. XML external entities has also been fixed with the disabling of the feature in XML that fetches that data for those entities. The eval modifier in pragmatch that has also been fixed in PHP 7. Remote file inclusion, we don't see that often anymore with Composer Autoloader. HTTP header injection, that's been fixed in PHP 5.2. That silently strips all the new line characters. Still, you might want to add some validation there, because if new line characters are ending up in your HTTP headers, something is definitely wrong. So you'll probably want to check for that. And we have lots of new improved features, like a good random implementation in PHP, and decent password hashing with bcrypt, proper defaults for HTML entities, and something like a blade or a twig that will automatically HTML encode. Now, as we've just seen, HTML encoding isn't the only encoding out there, so it always pays to look for the proper context, but definitely this will save you from a lot of XSS. We have PSR7, the message interface, instead of these dirty global variables, and PDO, prepared statements. Do use those in order to prevent SQL injection. So I believe that if you know the pentester, but not yourself, then for every validation added, you will also suffer a security bug. So we have to look not only at the bag of tricks of the pentester, but also at our own bag of tricks as defenders. And because security is a non-functional requirement, just like all of these, typically what we find in projects is that no one really thinks about that. No one stops to say, well, what about backup? What about performance? What about security? And the security is a bit different than these other non-functional requirements. Because unlike performance, you can't go to your customer and say, well, what is an acceptable level of XSS for you? Your customer will probably go back and say, what do you mean XSS? Well, include your an attacker may include his own content on your website. How about none? We need to, many flaws in security can be labeled as bugs. And what do we do about bugs? Well, we improve our software development process. So we start by testing properly. We go back in the process, and we make sure that we test for that properly. During implementation, we keep to best practices, security engineering best practices, and also in design, we also take into account some functional security processes. So typically nowadays that will be during Scrum grooming. So I will give you one help for that. One technique that you may use in your Scrum grooming in order to examine functional aspects of security, and that will be threat modeling. Now, this is a big and complicated topic, and there's much to say about it. So for now, I'm just taking the very simple approach that was in the book, as in ask yourself the 4 questions. What are you building? What can go wrong? What should you do about that? And did you analyze that correctly? So typically you would model what you're building. You can model that in many ways. Data flow diagram is often the most natural when you're building out a user story. And this might, for instance, be a story. As a user, I would like to reset my password if I've forgotten it. You might model that as such: an external actor at the top, the user, a message that's going down to a functionality, reset password, and a storage of passwords. So let's attack that. Let's attack that using Stride, which is an attack classification, which goes spoofing, pretending to be someone that you're not, tampering, changing the data, repudiation, so a user being able to claim that that wasn't me, information leakage, denial of service, and elevation of privilege. So in this case, if we would attack this, we might say, well, if a user is passing just an email and a password, well, that might be spoofed, because another user might give someone else's email name and a new password, and basically lock a user out of his account. Tampering, well, it may be tampered with. Someone may give an alternate password and thereby take over the account as it's traversing across the wire. Repudiation, that's not really in this model. Information leakage, we may be leaking that new password and that email across the wire if we're using a non-secure transport. And denial of service, well, you can certainly use this to enumerate through all the users in the system and lock them out. And elevation of privilege, well, if you can do this with an administrator, then suddenly you have a lot more privileges. So this might be another model that you then make based on those threats. You can try attacking this again, and you'll come up with new scenarios that might or might not be likely, but that's really something for you in the business to decide. Where do you stop with this? What are acceptable levels of risk? But that's not really for you to decide as a developer. And this is a tool to help you expose those security issues in your functional requirements. So, as the Russian saying goes, "Доверяй, но проверяй," which I probably murdered, but trust but verify. If you're not testing for security, then you're probably letting some security bugs go through. And fortunately, again, this heavily overlaps with how proper engineering practices are specified. So you can embed security, for instance, in code review, make sure that your developers are security trained, but are also using that security training in code review. You can embed that in functional testing. So something like a dynamic application security testing tool or something like an OWASP SAP might help you there, as in test your application as from the user's perspective over HTTP. Unit testing, it's best practice to, when you're unit testing, not only feed your unit test correct data, testing the happy path, but also testing the unhappy path. So what if I, instead of a string, enter a null byte or -1 or a gigabyte of data? What might my function do then? And one thing you might look into introducing is security testing with a standard like OWASP ASVS. So the one thing I like about security is that you have to look at it holistically. So you might have all these perfect defenses, but if your security or if your support person just hands out the password to a password inspector, then you're still hosed. So while this falls outside of the range of application security, it also pays to look at operations. So do you have the proper password hygiene? Are you using a password manager? Do you have two-factor authentication for your important services? Do you have a phishing program in place, typically specifically for non-technical users that will help? Are you encrypting the storage of your devices, say your laptops? What would happen if you left your laptop here? What would an attacker have access to? Test your system recoveries and ensure you have a firewall. These are all just best practices. So in the end, we go from beating the pen tester, hopefully, to being the pen tester, at least a little bit. Thank you.